Why is distinguishing surface and groundwater boundaries difficult? Imagine trying to draw a clear line in water that's constantly moving and changing. That's exactly what makes telling apart surface water from groundwater so tricky. These two water sources are linked through natural processes that are complex and always shifting. When it rains, water can seep into the ground, recharging underground aquifers. At the same time, groundwater can flow back into rivers, lakes, or wetlands. This ongoing exchange creates a fluid boundary that's not easy to see or define. Another challenge comes from the underground world itself. Aquifers are made of layers of soil and rock that vary a lot. Some layers let water pass through easily, while others block it. These layers can be made of clay, gravel, or fractured rock, and they don't follow neat, straight lines. Mapping these underground features requires special tools like geophysical surveys and measurements from wells. These methods give us clues, but they don't provide a perfect picture because underground features are hidden and hard to access. Water levels underground also change with the seasons and human activities. When people pump water from wells, it can lower the water table, making it harder to tell where groundwater ends and surface water begins. Sometimes, shallow groundwater measurements are missing or outdated, which makes it even harder to understand how groundwater supports nearby ecosystems or feeds into streams. Rainfall, irrigation runoff, and streams that lose water into the ground add more confusion. These sources can supply water independently of the groundwater system, making it harder to see where one begins and the other ends. Mapping tools like satellite images and topographic maps work well for surface water because they show visible features. But groundwater boundaries depend on geologic maps and well data, which can be incomplete or outdated. This inconsistency limits how accurately we can define these boundaries. In watersheds and drainage basins, understanding where surface water ends and groundwater begins is important because both contribute to the overall water flow and storage. However, because their interactions are so intertwined, maps often show surface drainage networks without clearly marking the underground parts. This makes managing water resources and protecting ecosystems more complicated. To get a better picture, scientists combine different data sources, topographic maps, geologic surveys, well measurements, and hydrologic models, and update them regularly. This helps identify areas where groundwater depends on surface water and vice versa. The main reason it's hard to distinguish these boundaries is because natural water systems are so complex, data can be limited, and water is always moving and changing.